Hello everyone, Boyd King at OSUIT, Institute of Technology in the Air Conditioning Department. I'm going to spend a little time covering how to ohm out and determine where the windings are in single-phase multi-speed motors. And there's two types of multi-speed motors in our industry that we see quite a bit in residential blower motors primarily, single-speed, shaded pole motors, and then PSC motors. And in our motor series that we've been covering, of course, you should have been through the PowerPoint already. All of the videos that I've posted up to this time, you should have went through before you get to this point. It's very crucial that you're going through here in progression. So the first motor we learned about was a typical shaded pole motor, and then we learned about a split phase, and then a capacitor start, induction run motor, and then the PSC motor. That's the last motor that we've talked about, is a permanent split capacitor motor. So now, multi-speed motors, multi-speed shaded pole motors, and PSC motors. We can identify these by the amount of wires that's coming out of them. You can see here, this is a wire with plenty of wires, or a motor with plenty of wires coming out of it. We have a black, two browns, a red, a blue, and a white, which I'll cover. Very typical color configuration. Now, how do we identify if it's a shaded pole motor or a PSC motor? Remember back on the PSC motors, I said very easy to identify because what's always going to be wired with the PSC motor? Permanent split capacitor. It's always going to have a run capacitor wired with a PSC. So if it just has some wires coming out with no capacitor, and it doesn't say on the nameplate that it needs a capacitor, there are some ways looking down into the motor you can tell. Remember, if you can see the windings, if you see two separate windings, it's a split phase configuration, a start winding and a run winding. If you just look into it and see one size of winding that's going through there, that's a shaded pole motor, and I know on the video you probably can't see this. This is a shaded pole motor, and we have a black, a white, a blue, and a red, okay? So there's three configurations that we need to memorize. And what I mean by configurations is how a multi-speed motor looks. That's what I mean by configuration. Shaded poles are very easy. We know that shaded poles primarily have one continuous winding. And I know I have this drawn like it looks like there's four individual windings. All it is one winding, in this case with 5 wire taps coming off of the one winding. And this could be, you could have 2-speed shaded poles, 3-speed shaded poles, or 4-speed shaded pole motors. I've drawn a 4-speed, a common, a high medium, a low medium, and a low. And what we're going to learn in this lesson is that we will see lowest resistance, or actually lowest resistance here, probably real similar resistance here, real similar resistance here, and a little higher resistance here. And then I would be able to take the readings between these 2 points, and it should add up to each one of these summed together. So if this was 5, this was 5, this was 5, and this was 5, I could ohm out between here and here, and it would be 20. Ohm out between here and here, it'd be 10. Ohm out between here and here, it'd be 15, so forth and so on. Shaded pole configuration. And then we get into our 2 different configuration possibilities for PSC motors. The most common way that you will see a PSC motor internally wired is this configuration right here. Here's a common, here is the high speed, possible high medium, possible low medium, possible low. Remember, this could be 2-speed, could be 3-speed, could be 4-speed. And then a start winding. And we've already learned that start windings have the highest resistance out of all of the windings. Matter of fact, the resistance between common and start will be higher than all of these added together. Okay, that's very, very important that you understand. Now, you would still, in this configuration, if you ohmed out between here and here, it would be the sum of this winding plus this winding plus this winding plus this winding plus this winding. So if this was 5, 5, 5, 5, and 20, 5, 10, 15, 20, and another 20 is 40, we would see 40 ohms between here and here. So configuration 1. Commons out here, high speed, mediums, and low, and start winding here. Configuration 2 is a little different. We have a common in here, we have a start winding that comes off of it, goes this direction, and a high speed that goes this direction, and then a medium and a low. Okay? And once again, it could be 2-speed, 3-speed, 4-speed. Now, once I actually get into going through the operation of how you do this, you have to start out assuming that it could be either one of these when you're trying to ohm out a PSC motor. Okay, now in your handouts that you had to get for theory, there is some in-class examples and there are some homework examples. I will be posting the homework assignments again, or the homework handouts on Canvas again, but you should already have these in your handouts. And so I'm going to erase this off the board, and we're going to actually go into looking at the ohm readings on them and ohming them out to figure out which configuration it is and what's what. Now, before we do that, I do want to talk about real quick the most common color codes. Please write this down. Please work on memorizing this. The most common color codes for multi-speed motors. And what I mean by color codes is what a black wire usually means, what a white wire usually means, blue and red and so forth and so on. 99% of the time, black wire is going to be high speed, red wire is going to be low speed. If it has a blue wire, it's going to be a medium speed. And white is common. So once again, white's common, black is high, red is low, blues are mediums. Now that was a shaded pole motor. This actually has 3 speeds also. This is a PSC motor though. That other one was shaded pole, this is a PSC. This one has 2 brown wires. These 2 brown wires we call extra wires, and as you see they have spades on them. They go directly to the capacitor. One of these wires will be your start winding, and I'll show that later on. Black's high, white's common, blue is medium, red's low. Memorize those. Write those down, memorize those. Let me make sure my video's still working and we'll continue on. Okay. So some examples, in-class examples of how to do this. First and foremost, you have to declare what kind of a motor that we're going to be ohming out here. This is a shaded pole motor. And so we know the configuration of a shaded pole motor. Let's look at the possible number of wires we have coming out of it, 5. So we just looked at the configuration of that. We know that we would have a continuous winding with 5 taps coming off of it. So that's what it would look like. The first step to ohming out a motor, either shaded pole or PSC, is going to be to find your highest resistance. So a 15, a 3, a 2, a 5, a 12, a 17, a 10, a 5, right there. That's our highest resistance. So we could go ahead and do the second step here with that, but we know that the two farthest outside points is going to be 2 or 4 here and 2 or 4 here. But we don't know which is which. So the second step that we have to do is go ahead and find what is the lowest resistance that goes with number 2 or 4. So we have a 7 here. We have a 5 right there. Look here, we have a 2 ohms between 4 and 1. So terminal 1 and 4, we have a resistance of 2 ohms. So there's 2 ohms right there. Third step. Now, we know where 1 is. What's the lowest resistance that goes with 1? So here's a 1 and 3 has 3 ohms. We have anything less than that? 1 and 5, that's not. So 1 and 3 has 3 ohms. Now we can do a quick check here and look at the sum between terminals 3 and 4. The sum between 3 and 4, is it 5? It is. And between 3 and 4 is 5. That's working. And now the last step, what's left? We've already determined this is terminal 2. This is terminal 4, 1 and 3. So we have 1, 2, 3, 4, and that would have to be 5. So what's between 5 and 3? 2 ohms. And what's between the last one, 5 and 2? 10 ohms. Okay? So now, let's do some double checking. Between 5 and 3, we should have 12 ohms. Between 2 and 3. 2 and 3, 12 ohms. Okay? Between 5 and 1, we should have 5 ohms. Between 1 and 5, we have 5 ohms. Okay? So there it is. We've discovered that wire number 2 is common, wire number 5 is high speed, wire number 3 is medium, wire number 1 is low medium, and wire number 4 is the low speed. Okay, and that's the objective that we're trying to do with ohming these multi-speed motors out, is declaring and finding out where high, medium, and low and common are in these motors. Okay, so let's do another one. Okay, make sure you can see that good. Okay, so what type of motor are we dealing with? We're dealing with the shaded pole motor. And how many terminals? 5 terminals, so real similar to what we just done. Terminal 1, 2, 3, 4, 5. Okay, what was the first step? First step is to find the highest resistance possible. 43, 32, 32, 21. Ooh, that's a big one. 64. 64 is our biggest resistance. So we know that this is going to be 2 or 5, and this is going to be 2 or 5. Now, let's find the next highest resistance, or the lowest resistance that goes with 2 or 5. Okay, so here's a 5 here with 32. Here's a 2 with 21, a 2 with 31. So right now this is lowest. Here's a 5 with 52. And here's a 2 that goes with 12. There is no number less than that. So, between 2 and 1, we would have 12 ohms. Okay? Now we know where our 1 is. Now let's find the smallest number that goes with the 1. Here's a 1 and 4 is 9 ohms, and that's the smallest number on there. So terminal 4 would have to be right there. Now we also know that this has to be 5 now. Last step, what's left over? We have a 1, a 2, we don't have no 3, so that has to be 3, 4, and 5. So what's between 1 and 4? 9 ohms. What's between 3 and 4? 11 ohms. And what's between 5 and 3? 32 ohms. Now let's double check, okay? A 9 and a 12 is 21. So between 2 and 4, we should see 21, and we do. That's right. Now between 1 and 3, we should see 20. 1 and 3. Yep, 20. So that works. And now last but not least, between 4 and 5, we should see 43. Now let me add right here, when you're actually ohming out these motors using an ohm meter, you will very, very seldom be exact to the number. You're going to have to do some rounding, and so most of the time we will be within 1 or 2 ohms from this working out. That's crucial to understand, that we're just introducing this right now, and we're assuming that all these are exactly whole numbers, but they won't be exactly whole numbers. Okay, so what do we know now? That this is common, because between 5 and 3 had 32 ohms, so this is the highest resistance on. There's high speed, here's high medium, and low speed. Okay. Let's move to a PSC motor. Okay, so PSC motors. We have to start with this right here on PSC motors. We have to start by drawing our 2 possible configurations. How many windings or how many wires are we dealing with? We're dealing with 5 wires. Now, one of these wires is going to be a start winding. So our 2 configurations, we have this. So a winding here, a winding here, a winding here, and a winding here. We have 1, 2, 3, 4, 5 wires. Or the most common configuration is that right there. Okay, now remember, it's crucial to remember that, matter of fact, I need to change that to right there. Okay. No, I don't. Okay, that was right. So crucial thing to remember is where is our highest resistance winding, our start winding right there. Now we can still do this very, very similar to a shaded pole motor. Our first step was to find our biggest resistance. And it looks like to me that 56 ohms is going to be our biggest resistance. Okay, so what does that tell us? Well, this is a little tricky right here. It's going to either be 4 and 5 ohms, or 4 and 5 terminal here, or 4 and 5 terminal there. And this one will be 4 or 5, and this one will be 4 or 5. Okay, so now the very next step is just like shaded pole motor, what is the lowest resistance winding that goes with a 4 or a 5? So there's a 9 that goes with a 5. Do I have anything less than that? I don't have anything less than that. 4 is a big number, 4 is a big number, 4 is a big number. So 3 to 5 is going to be 9 ohms. So I just discovered that out here has to be 5. Why do I know that? I know that because our speed taps are low, much lower resistance than our start winding. So both configurations, I have to be changing this on both of them because I don't know which configuration it is yet. So, but I do know that this is 3, that's 3, and that's 5, and that's 4. Now, here's 9 ohms right there. 9 ohms. Now, what is the next lowest resistance that goes with 3? Well, I have a 23, I have a 47, I have a 9. So this has to be 1, that has to be 1, terminal 1. And 9 ohms, 9 ohms. Now let's double check ourselves. How much resistance should be between 5 and 3 on both of these? Between 5 and 3, or I'm sorry, between 1 and 5. 1 and 5, I should have 18 ohms, and I do. So that's right. Now what's left? I've used a 1, a 3, a 4, and a 5, so this would have to be 2, and that would have to be 2. Okay? Now, this is probably the toughest part right here. Let's go ahead and write in our resistances. Between 1 and 2, we have 14 ohms here. And between 1 and 2, yes, I did have that wrong. So between 1 and 2, 14 ohms. And between 2 and 4, I should have 52 ohms. And between 2 and 4, now I got to write in here, what's between 1 and 4? Between 1 and 4 is 38 ohms. Okay, now right here is where you find out which one of these mathematically works. So if I add this up between 2 and 4, I should have 52. Between 14, from 2 to 4, I should have 14 plus 38. Do I have that? 42. That works. Okay, 52. Now, between 1 and 4 here, you see, it would be the sum of 52 and 14. So that would be 66. 66 between 1 and 4. And we've already discovered between 1 and 4, it's 38. That cannot work. It has to be this configuration. Okay? I'm going to do one more of those. Hopefully my video lasts that long. These are tricky. You need more practice on these than you do shaded poles. And this is a very, very good skill to learn. Okay, now here's one where we actually use the color codes that are common. Okay, so what do we start with? Well, this is a multi-speed. I'm going to do a PSC motor. Okay, we need to do another PSC instead of shaded pole. Okay, so this is a PSC motor, and it has 6 leads. We have to write our 2 configurations. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. This is not. Okay, so there's our 2 configurations. First step, biggest number. What's our biggest number? 61 is our biggest number. So we know that this has to be 2 or 3, and this has to be 2 or 3, and this has to be 2 or 3, and that has to be 2 or 3. Okay, now what's the smallest number that goes with 2 or 3? Well, here is a 5. Let's see if there's any. 21. There is a 2 that goes with a 3. I don't see any number smaller than a 2. So this has to be 3. This has to be 3, which makes this 2. Okay. Isn't that easy? We just knocked out, got 2 of them already. So this is 3. Now this has to be 5. This has to be 5. And there has to be 2 ohms right there. 2 ohms of resistance. 2 ohms. Okay, now what's the smallest number that goes with 5? So we have a 3 right here. A 3. Do we have any number less than 3? No number less than 3. 1. Terminal 1 between 1 and 5 has 3 ohms. Let's stop right there and double check. Between 5 and 3, we should have a sum of 3 and 2, which is 5. Do we have that? 1 and 3. 1 and 3. Yep, that's working. Okay, now, what's the smallest number that goes with 1? We have a 2 right there. I don't see anything smaller than that, so that has to be a 6. This has to be a 6. And what's left over? Only number left over is a 4. And so that has to be 4. That has to be 4. Okay, now let's go ahead and write in our resistances between 1 and 6. Between 1 and 6. 1 and 6, we had 2. 2. And between 6 and 4, 14. 14 here. 14 here. And in this one here, between 4 and 2, 40. Okay, between 4 and 2, this winding plus this winding has to add up to 40. So now, on this we have to write in here what's between 6 and 2. Between 6 and 2 is 50, 54. Okay, now, I can see right now that between 6 and 2 is the sum of these two. So 40 plus 14 is 54. That works. This does not work. It has to be that configuration. So now what did we just discover right here? Here's what we've discovered. Here's why we've done this. Is we know that this is common. Wire 6 is high. Wire 1 is high medium. Wire 5 is low medium. Wire 3 is low. And wire 2 is our start winding. Okay, so email me, call me. When you're working on these, I'm going to give you a homework assignment over this. I know it's tricky. especially in this format, having to learn it from a video, but study it. The good thing about videos is, remember, pause, think, write some notes, pause, and go back and watch it as many times as you can. That's the only advantage to be in quarantine like we are right now, is you have a lot of time to do this. Email me, call me, have a good day.